Hi, this is Matt Snape from TAFE New South Wales, here once again to talk about creating 2D presentations from the Inventor 2020 software. This is actually the third video in our little series here. We've already looked at creating base and projected views of a part or object that's already been created in 3D solid so that it presents in our 2D drawing. Then we looked at putting in center lines, two different types of center lines, a center mark and a bisector center line. So now we're going to look at actually putting some dimensions. So if you have a look at our drawing here, you'll see that it's as we left it at the end of the last video. Now, before I go on, what I want to do is show you one of the cool little tricks that Inventor does, along with most of the 3D solid modeling software programs that are available today, and that is it automatically updates any changes back in the original solid model. So when I do this dimensioning, I want to be able to show you an angular dimension, but everything in this model is sort of 90 degrees. So if I go back to my original block, the original 3D model, what I can do is I can alter it and I can add a chamfer here. I've cheated a little bit. I've actually already done that, so I'm just going to activate that, and you can see that we've now got that chamfer put onto that face. Now if I save this file and simply return back to my step block drawing file, you'll see there that it's automatically updated. So one of the great things about Inventor is that it allows that backwards and forwards sort of updating and that between the different files that relate all to the same models or the same solids. So without further ado, let's talk about dimensioning. So we were already working in our last video on the annotate tab. So we're going to need to stay there, and over in the far left is the dimension panel and the dimension command there. Now there's a few other ones that we won't go into at this point. Essentially what we're going to be looking at here is adding dimensions, so mainly linear and align type dimensions, so horizontal and vertical, and then a line between 2 points. Also angular dimensions, diameters and radiuses, and then we're also going to look at hole and thread notes. Now we can also add notes to chamfers, to sheet metal punches and to sheet metal bends, but we're not up to that stage yet, so we'll just put some of these onto this drawing. So I'll start by just hitting the dimension command and then coming back to our main drawing, and I'll just go here to our main front view, and it seems I'm still zooming the wrong direction all the time. In order to put a dimension on in AutoCAD, all we have to do is select an object or objects that essentially allow the computer to make the decision about what type of dimension it is you're trying to apply. If I just want to dimension the length of a line or an edge, all I have to do, as long as that line is complete from end to end, all I have to do is click on the line and it'll give me that dimension. In our dimension settings, we've got standard standard set off values, so you can see here that we get this little sort of magnetic click, so I can just click on that and it'll automatically align the set distance away from the object. And because we're actually working on the sheet, if this is at scale, it will present the dimension of the object. Okay, so it will show the true dimension of the object, but all the features of the dimensions, the height of the text, the offsets, the arrowheads, all that sort of thing, they will all be at the proper scale for plotting on paper. So it works really well, it makes it very easy. So that's just a straight linear dimension. Now if we're in a situation such as here where we've got an area we want to dimension sort of, from point to point, we can either pick a line or the end point of a line and then the other point. Alright, so we're still in the dimension command, so if I just pick end point and then end point, as long as that green point comes up, it doesn't matter. You'll see that if I push the cursor upwards, I get the horizontal component, out to the right and I get the vertical component. Alright, and if I sort of go somewhere in between, I get the aligned component. But if we want an aligned dimension and we can't sort of get it to work for us, what we can do is before we select or click on the drawing to place the dimension in space, what I'm going to do is right click, go to dimension type, and this is where it allows us to override and specify particularly what dimension we want to use. So if I wanted to use an aligned dimension here, I'd override that, and that then doesn't sort of give us those other choices, and we can get the standard standoff working, left click and place that on the drawing. So we could go through and continue doing those dimensions on as they're required on all the other views. Now, of course, we don't always dimension just physical objects. Often our dimensions go to center lines. So if we're placing dimensions to center lines, all we have to do is again click the line, click the center line, and that'll give us the dimension to that. All right, and because we don't, unlike software like AutoCAD, because we're not specifying particular particular dimension types, it makes the whole process much more fluid, but it does take a little while to get accustomed to it so that you are picking the correct objects the first time. So it does take a little bit of getting used to, but don't get frustrated with it because it is something that you'll soon be able to do. So obviously, set any of these center lines we can do dimensions to as well. The other thing to be aware of is that if you're doing dimensions that select to objects, so for example, in this situation here, if I wanted to do a dimension like essentially the length of that line, right? If I apply that dimension there and pull it up and left click, you'll see that the extension line goes all the way down onto the outline of the object to the end of the line that was chosen. So sometimes we need to make sure, and I've just hit escape to get out of the command, select the dimension with a left click and hit delete to get rid of it. But in order to make sure we don't get that, I'll restart the dimension. I'll pick that endpoint and that endpoint, and again we get up like that. So don't forget that you still need to pick particular points, and that depending on the way you want the dimension to display. The other thing that I was going to say also is that if you want your dimensions to line up, especially between views, they'll often not do that automatically, especially if you're dimensioning a surface or a series of lines that are not collinear, so they're offset to each other. You'll end up with that automatic offset actually being a different distance for the different dimensions. So in order to do that, once you've placed a dimension, if you make sure you're out of the dimension command, when you come over a dimension like this, you'll see that it actually gives you the ability to pick it up and move it around. So you can actually pull the text out and all that sort of thing. It'll still snap back to the center, all right? But if you want it to line up with another dimension, just drag over, pause on the other dimension there, and what it'll do is it'll sort of give you that line, and it'll give you like a magnetic snap, so you can drag it back and release it in the correct position. Alright, so that works on the same view very well, and it also works across views as well. So that's just a little trick to get dimensions more readily aligned. If we hit the dimension command again, we can see that angular dimensions are easily applied. I'll just zoom in here. Just pick the line, making sure not to pick a point, because then you'll get a different type of dimension. Pick the line on the other side, and here you'll see that we'll be able to, depending on where we move the cursor, as to exactly what dimension that we see. So I'd probably place that one there. Alright, so that's our linear, our aligned, and our angular dimensions pretty much taken care of. Let's have a quick look at radius and diameter dimensions. Now, you still only need the one dimension command activated. So again, it's just the object or the type of object you're selecting that controls the type of dimension that's created. So if we zoom into this hole here, excuse me, you'll see that just a left click, a simple left click on the circumference, okay, will allow us to create a dimension. Now this is a threaded hole, so that 10.1 millimeter diameter dimension is not what we want to supply. We want to supply the information for the thread that's required, and that way the person that's actually making the object or programming the CNC or whatever is going on, they'll actually be able to make their own mind up, depending on the metal and the situation and all that sort of stuff, as to what diameter holes to drill and what taps to use to cut the thread with. Right, to do that, we use our hole and thread notes, and we'll look at that shortly. Let's have a look though. If we want to apply a dimension, this time to an arc instead of a circle, you'll see that it defaults to radius. So the first one, the example that I had there, defaulted to diameter because I'd selected a circle. This one, because I've selected a radius, will default to a radius dimension. So if I let click there, and you'll see that it gave me like an automatic alignment tool that I could use if I chose to, and that will give me a radius. Now with either diameter or radius, if you're selecting the object and you're not getting the diameter, the dimension type you want, again, before you place the dimension, right click, dimension type, and it allows you to override it with any others that might apply in that particular situation. So I could easily override that with a diameter, and that will give me that result. So that's easy enough done. So that's pretty much the basic dimensioning that you need to do, with most sort of simple exercises Inventor taken care of. The other thing that we wanted to talk about though is hole notes. Now, notes in Inventor are really good, but you can only apply them if the feature that you're dimensioning is actually that specific type of feature. So for example, if I had simply drawn a 10.1 millimeter diameter circle on this surface and cut that into the object in the 3D model, then I wouldn't be able to apply a thread note to it. But because I created it using the hole feature, I can now apply a hole note to it, and that will give us the thread specifications and the depth of the thread as part of the hole note. So let's just go ahead and delete that diameter dimension from there, and let's go up and activate in the annotate tab the hole and thread note tool. So left click to do that, and again it's just a matter of clicking the circumference of the object. Now it'll be quite happy if you select the outer circumference or the inner circumference. So I'll just left click either of those, and I can put my thread note up here, and you can see that it automatically puts in M12, our diameter, by 1.75, our thread pitch, 6H, which is the fit class, and then a depth of 24 millimeters. So that would give us the person operating the equipment that's making this part all the information they require, and it's certainly a lot easier than having to put dimensions for depth of holes and all that sort of stuff. Now, if there's a specified depth of drill hole and specified depth of thread required, then you would need to put another dimension on, and that dimension would be the length of essentially this line. So I'll go from there to there, and that would give us the depth dimension there. So normally though, it's actually the machinist who's going to be the one that makes up their mind how deep the hole needs to be. That's for a clearance for a faster, and also to now enable easier and more rapid machining of the thread. It's normally not specified for any other reason other than that. So the only other note we can really look at here is our chamfer note, and all we have to do with that one is activate the chamfer note. Once again, we're back up in the annotate tab. Come down, and what we'll normally do is pick the chamfered edge. So this is our first edge here. Click, and then it'll ask you to pick a reference edge. So I'll pick an adjacent reference edge, and you'll see that that gives us our chamfer note. Now, which edge you pick first will control the way that this displays. So what that's saying is that we've removed 6.7 millimeters of material off this edge, and that this is 75 degrees to it. That's not the way you'd express this particular chamfer. If I hit escape and go back and reactivate chamfer, this time I'll pick the chamfer edge, and I'll pick this one here. you'll see that that's a 25mm long 15-degree chamfer. So it's actually, there's 25mm of material missing off this face, and it's a 15-degree. So that was actually the one I want. So you can see there again, the way the dimensions behave, the way they display depends on the objects you pick and the order you pick them in. So that's pretty much it for what I wanted to cover, just the general dimensions, and also for hole and thread notes and chamfer notes we managed to cover at the same time. We've also looked, of course, on how we get drawings automatically updating in Inventor. So that's another really useful tool, because when that happens, it means you don't have to re-prepare drawings. They just, all the views automatically update. So I certainly hope that's been helpful. In the next video, we're going to be looking at section views. And that should pretty much cover off on everything that we wanted to do. And again, this is all relating back to my 2020 Inventor fundamental notes using the 2020 version software, lesson number 16. So we'll see you in the next video. Feedback would be appreciated. Go and have a go at the software, and I will speak to you again soon.